So here are the highlights of plant evolution. The fossil record chronicles these four major periods of plant evolution. We have the bryophytes, the ferns, or these are also known as the seedless vascular plants. We have our beautiful gymnosperms, and then our angiosperms. Each stage is marked by evolution events of the different structures that we have mentioned previously. Basically, we are paving the way for these guys to make their transition to land. As I go through the different slides, I recommend you come back to this one to kind of get the bigger picture of the highlights. Let's get to it. First up are your bryophytes. These are your mosses, your liverworts, your hornworts. 470 million years ago is where we have evidence of our bryophytes first appearing. And these guys have structures that protect their gametes. These are going to be their haploid cells that are going to go on to contribute to future generations, and their embryos. So these guys are non-vascular. We're not going to see a xylem or a phloem or any type of vascular system that's going to transport water, minerals, nutrients throughout the plant. They lack lignified walls. They don't have lignin that we discussed, and they do not have roots. They do not have leaves. Basic root and shoot system is lacking. Here I can see a great example of bryophyte area and their preferred habitat. Moist, it's got to be moist since they don't have that vascular system for transportation. They're just going to have a general area for absorption for that nice moist environment in order to get what they need to survive. They, however, moved from a complete aquatic environment, as you can see, to a more dry environment, just kind of being around a moist swamp-like area. They are going to have specific structures to help with this transition: waxy cuticles to prevent dehydration or water loss, and retention of developing embryos within the female's plant's body. So before, we didn't see this retention of the developing embryos, but now they keep it within their own structure, and this is going to help with protection of that delicate embryo as it grows. So they still need water to reproduce. That event is still going to require a complete aquatic environment. It doesn't happen on dry land because the sperm is going to need a medium in order to reach the female eggs. The sperm needs to swim through that environment, through the water that it's going to be immersed in. Pteridophytes, or ferns, seedless vascular plants is also how you're going to see this, about 425 million years ago, according to our fossil evidence. And they are going to be known as the first event to have lignin. This is hardened tissue that's going to provide support. It helps the plant grow taller. This is going to help provide for that root and shoot type system. Immersing into that dry environment, even more so than the bryophytes did. So we can see them colonize a greater variety of habitats. They don't strictly need to be found in those moist, semi-aquatic-like environments like our mosses. We are going to also see vascular tissue appear on this timeline in the pteridophytes. These are my xylem and phloem, used for transportation. These guys, however, still require water to reproduce, so even though they're in a more dry environment than those bryophytes, they still require that complete aquatic environment for the reproductive event because, again, the gamete sperm needs to swim in order to reach the female eggs, so that hasn't changed. But we did get lignin, we did get vascular tissue, greater variety of habitats because of those structures appearing on the timeline.